Welcome to Makai's technical video series. In this video, we discuss a program named MakaiSpan, which is a modeling tool specifically written for analyzing cable spans. This tool is part of the power cable module available with MakaiPlan Pro for planning a safe cable lay from the office. MakaiSpan is designed to assist cable engineers in accurately calculating the shape of the cable on the seafloor during a lay, including the free spans, the forces on the cable at the seafloor, bend radii, and shear forces and moments along the suspended cable. The inputs used by the software are bathymetry profiles, the physical properties of the cable, including wet weight and bending stiffness, and the applied horizontal tension. The software then calculates a full two-dimensional cable shape along the seafloor. Results are displayed graphically and can be viewed in tabular form as well. First step is to import the terrain data. Data can be provided in 2D format as KP versus depth, or in 3D format with X, Y, and Z points. After your data is successfully imported, it will be displayed in the table window and the profile viewer. The profile data shown in the table can be edited by right-clicking one of the data points and choosing either Edit, Insert, Remove, or Fill in Terrain Data. Fill in terrain data will fill in terrain points by linearly interpolating depth values between existing terrain points. In the Fill Terrain by KP dialog box, you will need to specify the delta KP to fill in. You can fill in terrain points for the entire route by right-clicking on the route in the Project Explorer and selecting the Fill in Terrain Data menu. Once a route has been loaded, you can run the model by selecting File, Get Suspension Solution, or by clicking on the Solve button in the toolbar. This will open the Analysis Case Parameters dialog box, where you can specify the start and end KPs to analyze, as well as the model parameters. The model parameters include horizontal tension, wet weight, and flexural rigidity, also known as bending stiffness. In addition to model parameters, you can also enter the critical span length and critical bend radius that you want to meet for this project. For this example, I'll use a horizontal tension value of 5,000 newtons. When the OK button is clicked and the calculation is finished, a new solution item is added to the Project Explorer, and the solution is shown both in the table window and the profile viewer window. The profile viewer window will show solutions along with the route. The red vertical lines indicate the points where either the span length exceeds the critical span length or the radius is smaller than the critical radius. If the user presses the KP marker button, the KP marker is shown and the corresponding row is highlighted in the table window. For this case, you can see that span length exceeds the critical span length for these flagged locations along the route. If I use the Zoom Window tool to zoom in on the flagged location, I can see a graphical representation of the cable across the selected span. The user can pan, zoom, edit the display settings, and print the graph by clicking on the buttons in the toolbar. This is an efficient way to move along the route and simultaneously have a graphical and numerical representation of the solution. The table window displays position data in X, Y, and Z, KP, slope, cumulative length, moment, shear, span length, bend radius, and the force at the touchdown point. There is also a TD flag column which states whether the segment is touching down. Any segments where the length of the span exceeds the critical span length or the radius is smaller than the critical radius are highlighted in red. In summary, MakaiSpan is an easy-to-use tool for rapidly performing span analysis and ensuring that power cables are installed properly on the ocean bottom. It integrates seamlessly with Makai's suite of popular cable planning, simulation, and installation tools. Please contact Makai to try the software or for more information. Thanks for listening.